In this video here, we're going to be looking at solving some exponential equations, just doing a couple examples that involve exponentials and solving those equations. So if you haven't watched the other video that I did where I actually went through the steps to how to solve an exponential equation and also went through an example on there, you might want to check that one out before you watch this video. That one explains, these are the steps that we take and this is why we take those steps. On this one, I'm just going to go ahead and do a couple examples. All right, so first example here, 8e to the 2x equals 20. All right, and I want to solve that equation for x. So first thing, when you have to solve any type of equation, identify what type of equation you have. Is it linear, quadratic, exponential, logarithmic? Is it a cubic or a quartic function like an x to the third or an x to the fourth? Is it a trigonometric equation? This one, since my variable x is in the exponent of the e, this one is an exponential equation, which means I need to use the methods that apply to exponential equations and not to any of those other ones, right? I'm not going to use the quadratic formula here because that's what I do for quadratic equations, right? I'm not going to just add, subtract, multiply, and divide like I do for linear equations. I got to do stuff for exponential equations. So when I'm solving an exponential equation, first thing I need to do is isolate the exponential term, right? The exponential term meaning the base raised to the power. So in this case, it's that e to the 2x. Right, my base is e, my exponent is 2x. I need to get the e to the 2x power all by itself on that side of the equation, which means I need to get rid of this 8. Right, so since it's 8 multiplied by e to the 2x, I get rid of that 8. And when I say get rid of it, I don't get rid of it, I just move it to the other side of the equation, but I move it by dividing. Right, so I divide things to the other side because it's 8 times that. So when you're doing that first step of an exponential equation, you have to isolate the exponential term. That's where you do things that are similar to linear equations. So if it's 8 times this, I divide it because dividing is the opposite of multiplying. If it was 8e to the 2x and then plus 5 at the end, well then I would do minus 5 on both sides to get rid of that plus 5. Right, so I do those basic algebraic things to move the numbers to the other side of the equation. All right, this is going to give me e to the 2x equals 20 over 8. I said that upside down. Right, so 20 over 8, which I can simplify that fraction. Both of these can be divided by 4, so that's going to give me 5 over 2. All right, so I get e to the 2x equals 5 over 2. Even though we're solving an exponential equation, we can still remember the rules of fractions and how to simplify fractions, and we should still simplify fractions when we can. Everything you ever learned in mathematics up to this point still applies even though you're learning how to solve exponential equations. So don't forget to simplify fractions and do simple things like that. All right, so we got e to the 2x equals 5 over 2. And I'm just double checking to make sure I simplified that correctly. Yeah, I did. Okay. All right, so we've isolated our exponential term. Right. Next thing, well, is this one of those simple exponential equations? Anytime you have an e raised to a power, it's not going to be one of those simple types of exponential equations. And if you don't know what I mean by a simple type, I did a video where I did a couple examples of solving a simple exponential equation. That's when you have, a base to a power on one side of the equation and then the same base raised to a power on the other side of the equation. This is not that. Right? Since I have e to a power over here, I'm not going to be able to write 5 halves as e raised to a power. Right? So I can kind of chuck that out immediately when I see that e raised to a power and then a number besides e on this side. It's not going to be one of those simple types. This is going to be one of the more complicated ones where I have to follow through my steps. Right? So first step, I isolate the exponential term, the e to the 2x. Remember, isolating the exponential term doesn't mean trying to isolate that x in the exponent. I can't divide this 2 to the other side of the equation. Whatever's in that exponent has to stay together until I remove it from the exponent. Right, so I can't just pick things out of the exponent and move them to the other side of the equation. I cannot touch that exponent until I kind of bring it down and get it out of the exponent. So don't make that mistake. It's a mistake I've seen students make kind of a lot in the past. Of well, let me divide that 2 so I just have the x by itself and that e. That's not the way it works, right? You can't just divide this e to the other side to cancel out the e so you just have a 2x on this side. Right? Those things don't work for exponential equations. What works for exponential equations is logarithms. Right, so once I isolate my exponential term, that's when I do the log on both sides. So I do ln of e to the 2x equals ln of 5 halves. All right, and like I mentioned in the video that I did where I explained these steps and kind of how to do them, we did an example. It's a real good idea to use the natural log on both sides of the equation. Natural log is the one that you use most often when you go through higher levels of math. Also, when you have these equations that involve an e, here when I do the ln of e to the 2x, something really cool happens. And if you recall, I did a video on the properties of logarithms and exponents and how like some of the cancellation properties. The natural log and the exponential function with base e are inverses of each other, right? So when I have an ln of an e raised to a power, the natural log is going to cancel out the e, which leaves me just that 2x on the left side of the equation. All right, so I get 2x equals the natural log of 5/2. Right, so that's one of the advantages of using the natural log on both sides as opposed to the common log or the log with any other base. If I use the natural log, then anytime I have an equation with a base e, the natural log is going to cancel out that e, and the exponent is what's left behind. Right, to cancel out an e, I have to use its inverse function. Right, remember I can't just divide the e to the other side of the equation to get the 2x by itself. The only thing that cancels the e is the natural logarithm, the ln. Right, and it's important because and I'll do some videos of these soon, but a lot of the models that we use, to model real life problems using exponential functions have a base of e, right? The e is the number we use as the base to model exponential things in real life. And so a lot of equations that you end up trying to solve, a lot of exponential equations that you try to solve have a base of e, so use that ln to cancel out the e. Right, just make sure you do the ln to both sides of the equation, right? Not just the one side to cancel e. You have to keep your equation balanced. Right, but once we cancel out that e, I get 2x equals the natural log of 5/2, and now I can go ahead and solve for x. Right, so I use my natural log, cancel out the e, I divide both sides by 2, and I get that x, and let me put this up here, x is equal to the natural log of 5/2 all over 2. All right, this is my exact solution. All right, now a couple things to point out. If my equation does not have base e, if it has a base 5, let's say 5 to the 2x power, when I put the ln on both sides, the ln will not cancel out a base of 5 or any other base besides e. Right, so again, the other video that I did where I explained the steps of how to solve an exponential equation, that one had a different base, so I would advise you to check that one out and watch that example to see what happens when this base is not e. Right, when it's a different base besides e and I put the natural log on both sides, there's like another couple steps that we have to do in order to solve for x. Right, if it's an e though, we just cancel out with the natural log. So watch that other video, look at that other example to see what happens when this is like a 3 or a 5 or something raised to the power. Right. The other thing I want to point out here is once I do the natural log on this side of the equation, I get ln of 5/2. I then cannot touch that 5/2. Right? When I divide the 2 over here, I don't do 5/2 divided by 2 and make it ln of 5/4. Right? ln of 5/2 is one number unto itself. And whatever that number is, I am dividing by 2. Right? And just to kind of show you what I mean, if I do ln of 5/2, I get 0.91629. Right? 0.91629. So that's what number is on the top of this fraction here. That's what number is getting divided by 2. Right, so I do that divided by 2, and I get my approximate solution for this equation, which is 0.4581. Right, so x is approximately equal to 0.4581. All right, so there's my approximate solution. Right, so when you are doing calculations or finishing up the last couple steps of solving one of these problems, don't make the mistake of saying whatever's in that side of that ln, oh, if I divide by 2, I have to take that number in the parentheses and divide it by 2. Those numbers don't mix, right? So if you did that and you got like ln of 5/4 here, if you do ln of 5/4, it's not going to give you that same number, right? It's different, right? The rules of logarithms say, or they don't say, if I have the ln of something and then I add or subtract or multiply or divide, it doesn't affect that number in the parentheses, right? So don't ever do that. If I had to add or subtract numbers over here, I don't touch whatever's in the parentheses of that natural log function. That has to stay in there. You can't touch it. All right, it's a common mistake I see people make. Right, so our exact answer here, and then our approximate answer. Read the directions for the problem that you're given. If it asks for the exact answer, and you're solving an exponential equation, most of the time that exact answer is going to involve a logarithm of some type. Right? If it asks for the approximate answer, how many decimal places does it want you to round it to? Most of our answers, most of our solutions to exponential equations come out to irrational numbers. So at some point we have to round off the decimals, which once we round off the decimal, it's no longer exact. It's now an approximate solution. This is the exact solution with that natural log in there. All right. All right, so that's one example here of solving an exponential equation. I'm going to pause the recording and then put up another one and work through that one a lot faster than I did this one. All right, so this equation here is not exactly an exponential equation, but it contains exponential elements. So it's 3x times e to the x power plus x squared e to the x equals 0. All right, so it has exponential stuff, but also has polynomial stuff. Right, it has a 3x and an x squared, multiplying those e to the x's. Right, so when you're faced with a problem like this, solving it in this form here is, I don't know if it's impossible, but it's pretty close to impossible. It's really hard to do. But what we can do is, if we remember some of our basic algebraic tools that we have, we can make this a lot easier on ourselves. Right, notice both of my terms here contain an e to the x, which means I can factor out my common factor of e to the x. And I get e to the x times 3x plus x squared equals 0. Now you might be thinking, well, they also have a common factor of x, so why don't I factor that out as well? We want to separate the exponential stuff from the polynomial stuff. So I just want to pull out that e to the x, so I have an exponential thing here, and then my other factor is all the other polynomial stuff put together. And then we'll separate these, and then we'll deal with the x that's in there in common in the next step. Right? But right now I just want to separate everything. All right, so I factor out my exponential piece of this, which is that e to the x, and then since I factor this, and I have two factors multiplied together equals 0, I separate my factors. So either e to the x equals 0 or 3x plus x squared equals 0. Right? And now I've got two equations, but at least I have my exponential separated from my polynomial, and now I can solve each of those separately. Right? So when you see equations like this, which come up a bit in precalculus, they come up every once in a while in calculus as well, and a lot of times students see this, they're like, well, I don't know what to do. I have an x squared times an e to the x. I don't even know where to begin. Begin by factoring out that exponential term, and then you can kind of separate them and proceed from there. Right, so to do the polynomial part first, 3x plus x squared equals 0. These two terms, like we just said, have a common factor of x, so I can pull out the x, which leaves me with 3 plus x in the parentheses. Right, so x times 3 plus x equals 0. I can separate those factors. I get x equals 0. That's one solution. I get 3 plus x equals 0, which when I subtract 3, I get x equals negative 3. There's a second solution to this equation. All right, so those two solutions will solve this original equation. Now, what about this e to the x equals 0? How do I solve that? Well, there's a couple ways to think about it. If I try to solve it like an exponential equation, well, I have the exponential term isolated, right? That e to the x is all by itself, so then I would do the ln on both sides. Right? ln of e to the x equals ln of 0. The ln and the e cancel out, just like they did in that last example we did, so I get x equals ln of 0. Now, this should be, a warning, bell should be going off in your head right now. What is the natural log of 0? Let me type that again. So if I have natural log of 0, and I type that in my calculator, I get error domain. Right? If you recall from some of the other videos that I've done before about logarithms, the domain of the logarithmic function is positive x values. Right? X has to be greater than 0. I cannot do the logarithm of 0. I cannot do the logarithm of a negative number. So if I get x equals ln of 0, ln of 0 does not exist. Therefore, there is no solution on this side of my equation. Right? This e to the x equals 0, that equation itself has no solution. Right? So going back to my original equation, the only solutions come from this other side, x equals 0 and x equals negative 3. Right? That e to the x doesn't offer me up any solutions here, because e to the x never equals 0. Another way to think about it, if you recall the graph of an exponential function, it looks like this. Right? And it has that horizontal asymptote at y equals 0, which it never touches. Right? So this graph will never reach y equals 0, so e to the x can never equal 0. Right? So anytime you have an equation that involves an exponential equal to 0, if it's just a base to a power equals 0, there's no solution there. All right, so there's a more complicated type of exponential equation.